Okay, now today we'll start with some problems which I gave yesterday and try to show you some more problems which are there in single linked list before we move on to double linked list. Now here there were few questions which I gave yesterday, two of them. Now let me tell you one or two more questions which are there, which are quite important for your practice as well as for your knowledge. Let us try to give a third question. Now write algorithm to reverse a linked list. Now you know that it will be something like this. Now this is the linked list given to you. Now what the output what I want is something like this. This is the output I want. This is the input and this is the output. Okay. Now when you are going to do this, you have to make sure that apply only one traversal. Now what should be the output and how can you proceed with this problem? See, for this one you have to be very careful, otherwise to make some wrong steps you will break the linked list, and therefore this has to be taken care very well, otherwise you will be breaking the linked list. Now this is a very good question because it involves a lot of concepts and you will know how to manipulate the pointers. Now just I'll give a small hint so that you can try. Is that hint?
Sir, we will take two pointers start and end and we will interchange their positions with the help of the third pointer using swapping.
How many pointers you will take?
So three pointers, one is the start, another one is end, another one is temporary, anything. And we will do swapping, sir.
Okay, that is what you have to do. But only thing is that you have to make sure that while you are doing this, you don't break the things. That means, okay, you can take 3 pointers. Let us take a 3 pointers. Let us take it as a previous. Then you can take a current, and you can take say next. As the name says, previous is the one which points to the previous node, current points to the current node, and next point to the next node. Now here, if I start with the first node, current contains a start, whereas previous and next will contain, initially it will contain null values. That means put current is equal to start, put previous is equal to null, next is equal to null. Then you perform an iteration. You iterate in the loop. Now before changing the next to current, now what you do is that you store the value of the next node. That means what will happen? Next will contain the next node after current. Therefore, if you are going to write like this, next is equal to current of next, before that you have to save that value. Now this is, and then you write current of next is equal, I just write 2 lines and you just try to say how it will work. I just write 2 lines for this. Next is equal to current of link is the first statement, and the second is that the current of next is equal to previous. The current of next is equal to previous. What I am writing previous. The current of next is equal to prep. Okay, these are 2 statements.
Sir, current is initially null, so sir, how next equals to current of link is a meaningful statement.
Pardon?
Sir, I'm asking, sir, current is initially null, so how next equals to current of link is a meaningful statement.
No, therefore, in that case, you have to first of all, while doing that, you have to take those values. Now, initially, this will contain the current will now say this will contain the value of start.
Okay.
Now, this will initially contain null. This will also contain null.
Okay.
Now, here, once you are going to current of link, this is not null. Current means the first node, which is the start. Now, those 2 nodes are obviously used, but initially they will be put as null. And now, once you are writing this statement, this will point to the next node after current. And then you are going to move current over there. But this is just for the reversing. Now you have to after that you try 2 more statements, which are nothing but you have to move previous and current 1 step forward. Therefore, what you will do is that after that, what you will do, you have to move 2 nodes are there. One is previous and current. Previous and current 1 step. What you do is that move previous and current 1 step forward. That will be 1 step forward. That's all. This will solve the purpose. That means you are going to use this concept to solve the thing. So initially, suppose initially what you are doing is that in this way you will not break the link. Otherwise, what will happen in any case, if by mistake you are going to say break this one, then you lose the track of this node. You are going to lose the track of this one to over here, which will be there, because you will now lose the track. Therefore, before doing this, you have to keep on saving the things. Okay. Now, after you are doing,
Sir, you are not clearly audible.
Pardon?
Clearly audible नहीं हो रहा.
Actually, I'm not clear. See, what you have to do is that once you are going to do like this, you have to make sure that links are not broken. Okay. Now, just to take one linked list of say 5 nodes and try to apply this algorithm, you will be ending up in getting the reverse list. Now, what is the order of this? What is the order of reversing a linked list by this method? It's order of n.
O of n.
Order of n. Capital O of n. Because you are only starting from the first, the last. If order of n, mostly the algorithm will be done in order of n times. Okay. Whether it will be done in strictly order of n times is not always true. It can be done, it will be done in order of n times, but might be done in order of, say, n, but not strictly order of n. When I talk strictly order of n, it means that it should not be more than order of n. If I take, say, order of n, it means order of n, 2n, 3n, 4n are all order of n. Okay. Now, these are the problems. Other than that, there are a lot of problems which you can do. For example, one of the problem is that you are going to use the algorithm to create a sorted linked list. Now, if you are going to do this now, once you are going to write this problem is quite good, because of the fact that this problem is, let us try to, this is a programming problem which you can do, but only if you have done the smaller problems very well. For example, create a sorted linked list. Now, this problem is little, say, lengthy. Why? Because this involves all the insertions. And you can also say, you can also have it all types of deletions. Now, in this means what is happening? For example, just take the numbers. Example, suppose I want to create a linked list with 8, 6, 15, 25, 4, and say 30, and say 2. So these are the numbers. And I want to create a sorted linked list for this. Now what I do? I create, first of all, I create 8. For this, you require the algorithm to create a linked list. Okay? Then you get 6. You compare with that is less than 8. It is less than 8. Therefore, you add 6 over here. Now this is nothing but insert at beginning.
So numbers are not initially placed in the linked list.
What are?
Not initially placed in the linked list. We have to create a sorted linked list. मतलब सर सिर्फ नंबर दिया रहेगा, फिर हम लोग को sorted linked list में ही डालना है उसको.
नहीं, numbers will keep on coming one by one from you, and you have to
Okay.
find the best place to insert that. That
Yes.
only place to insert that. Therefore, चाहे वो दिया रहे, चाहे तुम हर बार इंटर करो, बात एक ही है. ठीक है? इसी ऑर्डर में आ रहा है. The meaning is that the order is now in this manner. That means inserted beginning किया तुमने. Now next node आया 15. अब यहाँ पे start जो है, obviously now start will now point at this place. Start आ जाएगा यहाँ पे. Now next number is 15. 15 is obviously bigger than 8. If not bigger than 8, first bigger than 6, then bigger than 8. Therefore, तुम यहाँ 15 insert करो. Yoga insert at end. ये तुम्हारा यहाँ पे ये हो जाएगा. Then again 25. Again you will insert 25 over here. Again same होगा. Insert at end. Then 4. Again 4 यहाँ insert होगा. Then you will get say 30, something over here. Now suppose this is 12. Then you will insert 12 somewhere here. Therefore, and this is insert. This is create node. Now you see how many types of algorithm you got. You got one this type of algorithm, insert at beginning, second type, insert in third type, insert in middle, fourth type, and you got all the 4 types of algorithms. Similarly, if I tell you delete 30, if I tell you say delete 30, then what you are going to do? You will delete at last. You will delete at last. If I say delete 8, delete at middle. If I say delete 4, delete at the start, and so on. Therefore, by this method, you will be ending up in getting all types of algorithm. For this, what you should do is that you should be able to write functions, and those functions will be called as and when you find the position for that. Okay. Therefore, that is one way that you can.
Sir, pardon, please, sir. What, sir?
You write functions.
Pardon, please.
You write a function for insert at end, insert at beginning, create. Then now, when you find that start is equal to null, you call create. Then you get another number. You find whether I should call insert at beginning or insert at end or insert in middle. Now, after you create a linked list, there are only 3 things you can do: either insert at beginning, or insert at middle, or insert at end. You just check whether it's in which of the algorithm has to be called, and using that you can try to call that algorithm. By this method you can do this. Now this you can only try once you have programmed individually those algorithms, because this might involve say 8 algorithms, because 4 in the creation and 4 in the deletion, therefore it might contain up to 8 algorithms, and all those 8 algorithms has to be called using either a switch case or in any way you want. But the main thing is that you should be able to get a perfect sorted linked list. Okay. Now this problem is there. Now,
And sir, at the first, sir, we need to store those numbers into an array, and then we will compare.
don't do like that. You just scanf one number, and then you find the proper position of that number, and then call that thing. Again read one number, again find the position of that number and call that corresponding algorithm or corresponding functions. Then again keep on doing until a maybe person who says I don't want to end anymore. Then the person might say delete, or you can do you might say insert, delete, delete, insert, 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 delete, and so on. Any combinations. But the meaning is that you take one number, find the correct position to insert and insert it. Take one number, find where it is and delete it, and keep on doing like that. Okay. Now this type of algorithms are quite good algorithms, and this will give you a good number of things what you can do. Now, yesterday I have given, there are some more problems which I will give, but maybe tomorrow the next class I'll try to give you a lot of problems which you can do. Just you can try over here. Now in the last question where I gave you a problem to find the common meeting point of a linked list. Okay. Now this problem has many solutions. Obviously, some I'll give you one of them today. You can try to find other solutions also. Now, it is a question will be like this. Something like this, where there are, say, some nodes. Now here S1 to that meeting node. Now this is the meeting node. Now this is the meeting node. This is the meeting node. Now here, this could be any number, and this could be any number. Now I propose solution number 1, and you tell me, is it a good solution or not a good solution? Now what I do is that I take one pointer over here, maybe called, say, temporary 1, and one pointer over here called as temporary 2. Okay. Now I write two loops. I write two nested loop. Where the outer loop will be for S1, and the inner loop will be for S2. If the address is same at any point, then it is the meeting point. Now, in the first, that means what I do is that I will say with T1 at S1, I will try to traverse from T2 to last. That means taking this one as 1, putting a T1 at this place, I will just start like this. Then again, if I don't find, I will match with this address. Suppose this address is 2400. This is 2420. Suppose this is 2480. This might be 2510. This might be 2460. This might be 2520. Like this. Now here I compare this 2400. I will compare this number with all of them. Now I find 2400 is not equal to 2510. I move forward, compare 2400 with 2460. Keep on doing until the second one exhausts. If it reaches to the end, I now point T1 to this place. I point T1 to this place. And now I compare 2420 with this, and keep on doing. I compare 2420 with 2460, 2420 with 2520, 2420 with 2480, and keep on doing until the end. Again, if it is not found, you are going to increment T1 to this place. Now I compare 2480 with 2510, then 2480 with 2460, then 2480 with 2520, then 2480 with 2480, because now T2 will now move to T1, and then I find that the address of T1 and the address of T2 is same. It means that 2480 is the meeting node. Okay, that means first of all you compare 2400 with all nodes of T2. Then you compare 2420 with all nodes of T2. Then you compare again 24, maybe 80 with all nodes of T2. And a time will come when both of the T1, T2 will point to the same node. If you are going to find both at the same node, it means that that is the meeting point. And this is one solution. Now, quickly tell me, what is the complexity of this algorithm?
Sir,
O n
4 to the
square.
power, sir, n square. Mn, sir.
Order of n square.
Length of
Below Mn.
Or you can
S1
say
If
into
m is the
length of S2.
if m is the number of the
Length
sir
of
first
S1
linked
into
list
length of
and
S2.
n is the number of the second linked list, then the time complexity will be big O of Mn.
order of m into n. Let's
Yeah.
try take one contains m nodes, one contains n node. Therefore, it could be order of m into n. That is order of m square or n square same. Obviously, not good, but obviously it is answer is correct. Now this is one solution. Did you get a solution? It's okay. The solution is there. You just stop. You are going to take one point at one position and try to find with all. Then you move it further, again do it with all. Third one, again do it all. If it is not meeting, the T1 or T2 both will come to the end, and then you find. Now, what is if it is not meeting? Then what will be the condition? Suppose these two linked lists are totally independent and there is no meeting point. So what is the condition for that? Suppose both are independent linked list and there is no meeting point. Okay, here what I am thinking that there is a meeting point. There could be scenario where there is no meeting point. तो कैसे मालूम करोगे कोई meeting point नहीं है? Correct. यानी जब T1 पॉइंटर पहुंच जाएगा लास्ट में, इसके मतलब मीटिंग पॉइंट नहीं मिला अभी, आउटर लूप ये है ना, जब आउटर लूप का पॉइंटर पहुंच जाएगा यहाँ पे, देखो इन दैट केस इफ T1 will reach here, it means that there is no meeting point because T1 move कर रहा 1-1, T2 move कर रहा for because inner loop पे T2 है ना, तो that means T2 will reach to end many times, but T1 will come to the end only one time. If T1 of link is equal to null, it means there is no meeting point. Is it clear to you that if T1 of link is not equal to null, it means there could be a meeting point. If T1 of link becomes null, it means there is no meeting point. Okay. Now tell me that this problem what I did, this one, not this, sorry, this one. What could be other method to do this? How can you do what can be the other method to do this?
Sir, we can just swap the data element from the first and the last node. With that,
How will you reach to the last node?
yeah, first node and the last node. Like in the start, then we will swap the data element of the first node and the last node, and simply we will decrease a pointer from the last node to the n-1th node and first node to the second node pointing, and then we will swap those numbers. And for that,
Okay.
we need to first transverse up to last, and then we can do this.
Acha. Okay, now I got you answer. But tell me, what is the problem in doing like this? You said that from last I'll move one backward to n-1. How can I move from last to n-1? Because I cannot go backwards.
Yeah, yes, sir. That is possible in double linked list. Yes.
It is not possible directly. It is possible, but you have to maintain some additional data structures for that. The one solution what you should have come up, because you have already done the basics, is that what I can do, I can maintain one stack. and the stack should contain the data element as well as the addresses. Therefore, what I can do is that I can maintain something like this, a double stack like this, where this part is the data and this part is the address of that node. Now, as and when I am going to move, I will put data over here and the address over there. Then again data over there, address over there. Data over here and address over there. Data over here and address over there. Once I get null, I start popping out. And then I will get D with the address, put it over there, create a linked list. Then pop C, insert at end. Again pop B, insert at end. Pop A, insert at end. And I will get something like this. Do you agree with me? Or there is better solution for this? Are you getting it? What I said? You take a stack, put the data as well as put the node of this. For example, this might be say 2140, this might be 2150, this might be 2200, this might be 2260. And I will put this address as 2140, 2150, 2200 and 2240. I can maintain a stack, push all the numbers, all the nodes from first to last, and pop out one by one and call the algorithm insert at end. Now I want a better solution than this. Or can I say lessen the burden of the stack?
Pardon, please?
Can I lessen the burden of the stack? Do I need to? Now the question is, do I need to store the data as well as the addresses?
No, sir. Only we can store address.
Correct. Data is not needed because once you are having the address, data is not needed. जब तुम 2140 ले रहे हो तो डेटा उसके अंदर होगा ही. Therefore, I intentionally made it wrong. Because not wrong, I intentionally made it an additional information which is not required. तो actually में तुमको ये नहीं चाहिए, तुम्हें ये नहीं चाहिए. This is not needed. You can only do with the addresses, because if you push 2140, obviously it will contain the data at 2140 also. So basically what I am trying to do, I am just putting those addresses. When I pop 2140, obviously the data will be there inside, because अभी हमने को हटाया नहीं data को, data is obviously there. Therefore with this only I can do. Therefore what I can do, I can maintain a stack which only contains 2140, 2150, 2200 and 2260. And I push all. Then I take 2260. Obviously when I take 2260 out, it contains D. And then you will have this node. Then you again call 2200. It will contain C. Call the function insert at end, and this will attach like this. Again you call pop 2150. This will come here, and it will come here. And a time will come when the stack is empty, you stop. Therefore, there could be many solutions, but obviously this requires an additional stack. Therefore, the order of complexity for this, कितना order of complexity कितनी है इसकी? What is the order of complexity of this algorithm? It is correct. 2n. N for pushing in the stack और adding के लिए 2n. Is it actually 2n or more than that?
It's more than that
कैसे?
because we can add we are doing something else also.
What something else?
Mm,
Let us clear the doubts. Why 2n was said by one of the student is that once you are pushing ABCD in the stack, it requires n times. Once you are popping the elements from there, it again requires n times. But what I said that you are calling insert at end every time. How much time insert at end takes? Order of n times. तो traversal करना होगा, है ना? Therefore, it again requires order of n times for all the elements. Therefore, it is order of n plus order of n plus order of n square. Why? Because every time we want to add an element at the last. Therefore, but one student wrote order of 2n, which is also possible. बताओ. Amir Javed, you tell me, how did you come up with 2n? Your answer is correct, but let me ask you, कि additional pointer कौन सा लोगे?
Sir, the pointer at the end of the linked list.
Now that is an intelligent use, correct? Good. What you can do is that when you are going to you pop D, of course, when you are going to now let us try to see what is the actual what can be done. Just by using a small modification, you can convert the algorithm into a better one. अब क्या होगा? Now let us try to see. हमारा ऐसे stack है. इसमें नंबर्स है तुम्हारे. ठीक है, यहाँ पे टॉप. Now what you are going to do, you are going to pop 2260. Correct? But what you do is that you maintain one more pointer over here. Maybe you call it last. Then what I am going to do is that I am popping 2200. With the last pointer, I will attack this. And now last will come here. Again, I pop 2150. Now with the last pointer, I can like this. And I will move last over here. Then again, I pop 21, whatever, 2150. And I will add like this. Now let's take the complexity. Once you push the element in the stack, it is order of n. Once you're going to pop the elements from there, it's order of n. Now tell me, अब इसके आगे क्या होगा?
Sir, O of 1.
O of 1 कितनी बार? ठीक बता रहे हो, O 1 कितनी बार?
जितनी लेंथ है लिस्ट की,
That means it will be order of
जितनी
1
लेंथ है लिस्ट की,
plus order of 1 plus order of 1. How many times? Number of times you are going to enter the elements. है ना? Therefore, actually it will be approximately order of 3n. Because order of n for pushing in the stack, order of n to, therefore ये basically push के लिए है, ये pop के लिए है, और ये जो तुम्हारा है, ये insert के लिए है. Because order of 1 n times will make it order of n. Therefore, it is actually order of 3n. Because अगर order of n फिक्स 2 बार 3 बार होगा तब उसको तुम अवॉइड कर सकते हो, बट ऑर्डर ऑफ 1 अगर 9 टाइम्स आएगा तो तुमको उसको अवॉइड नहीं कर सकते. आर यू गेटिंग इट? जिससे मान लो तुमने लिखा ऑर्डर ऑफ सी प्लस ऑर्डर ऑफ n प्लस ऑर्डर ऑफ 5, ये होगा ऑर्डर ऑफ 2n, बिकॉज 5 इज फिक्स्ड. बट अगर ये 5 नहीं हो के ऑर्डर ऑफ 1 प्लस ऑर्डर ऑफ 1 प्लस ऑर्डर ऑफ 1 n टाइम्स हो जाएगा तो वो भी ऑर्डर ऑफ n हो जाएगा. यहाँ पे प्रॉब्लम क्या हो रही है कि ये जो सारे वैल्यूज हैं ये n टाइम्स हो रहे हैं. इसके मतलब ये 5 नहीं होके ये n टाइम्स है. If I told you order of 100 और order of 1 ये दोनों सेम है, because 100 is independent of n. बट अगर n आ गया ब्रैकेट में, that means it is dependent. अगर मान लो 1 million, just take n is 1 million, तो क्या हो जाएगा? Order of 1 million plus order of 1 million plus order of 1 plus 1 plus 1 plus 1, 1 million times, which is equal to order of n only. Therefore, it is approximately order of 3n, which can be done. Now, these are the variations. Now, is it possible to further reduce the complexity? Now, it's up to you. क्या इससे और better हो सकता है? Now, in the next class, what I want is that you find the better solution for this one, this question. You find the better solution for this one, which should not be order of m into n, but should be order of m. ये हमें order of m चाहिए, ये order of n मतलब, so that you will be able to get a better algorithm than this. If I can get this, okay, that's algorithm is there. At least there are minimum 3 to 4 solutions are there. The one I gave is not a good solution, but it will work for sure. Now stop at this point. The next class I'll give you 3 more problems to do. Then I will do a circular linked list, and then I start with double linked list. A question you last for, like, what if we store the data in stationary addresses? Okay, just a moment. This question is asked by a person. What if store data in stack instead of address? Then during traversal original linked list, we can simply keep popping data and put them in the nodes of the original linked list itself. This removes the need of manipulating pointers. What if store data in stack instead of address? Okay. No, if you are going to store data, how will you know the addresses for that? Suppose I only store A, B, C, D. Now here, if I pop A, how will I know what is the address of A? Because those are not contiguous. Just what Yash is asking, that can I only store data in the stack? If you can do that, it may look that the reversal is done, but actually there is no reversal. one thing is very very clear, make yourself very clear. एक होता है physically reversal होना, एक होता है आंसर लाना. Now what I am trying to say, you should be very very clear. Now this is algorithm. आंसर जो है ABCD है. I can get DCBA also, but DCBA is not the reversal. रिवर्सल के मतलब लिंक्स रिवर्स होनी चाहिए, डेटा से नहीं होगा. जो तुम बता रहे आई एम गेटिंग, तुमने क्या किया, ए डाल दिया, बी कर दिया, सी और डी कर दिया, उसके बाद तुमने सिर्फ डीसीबीए निकाल दिया, बट वो फिजिकली रिवर्सल नहीं हो रहा. इट इज जस्ट ए वे टू प्रिंट द आंसर्स. अगर हम तुमसे पूछेंगे कि बताओ सी का एड्रेस क्या है, it will not be a physical reversal. It will just be the data. If I ask you over here, what is the address of C? You can't say. Therefore, that is a way to print the things, but you cannot do that in this way. Therefore, this is not a correct solution. Though it is, it looks that we have achieved the answer. Therefore, what I will expect is that we'll expect you to give solutions for this one, and plus some more questions are there. For example, a question which I'll do in the next class is that for a linked list which contains which is nothing but a circular linked list, and try to get the solution for those concepts. Therefore, we'll keep on doing a lot of questions, and we'll end up in writing good number of programs so that you will be able to know these concepts.